Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
All right. Well, welcome everyone. Today we have with us Magnus. What's your last name, Magnus?
Madsen.
Madsen. Awesome. From who lives in Aarhus, and I hadn't heard of the Flix programming language, which we'll get into, but it came across like Hacker News and stuff a few months ago, and when Bruce and I started looking at it together, we went to the design principles page, and I was like, oh my God, this programming language is like everything that I've learned in the last 25 years of programming or something. I was just shocked at how aligned it was with everything I believe in the principles so anyways, I was like, we got to have Magnus on.
Well,
Thank you.
and
Those are some
fact
kind
that
words.
you started out with design principles, or at least you developed them early on. You know, Python eventually had the Zen of Python, but that was long after the language was created. Whereas it seemed like you said, here's what I want to do. I want to solve all the problems. and it's like, was that an option all along? I didn't know that was, because it seems like every time I pick up a language, it's like, oh, and then you decided to do this, and now I'm disappointed because you didn't really think that through. I mean, right now with Scala, I am really having a hard time with the infinite operator overloading thing, because it's like, no, that doesn't help people understand things.
There clearly wasn't a design principle, which here, let's pick one. Simple, not easy. That's a good one. That I would say maybe the operator overloading isn't aligned with that principle.
Yeah,
maybe a few others.
I think, when we started working on the language, we also actually didn't have any principles in the very beginning.
Huh.
But then over time, right, as a language designer, you're suddenly forced into making some decisions. And then instead of just saying, like, why should I do it like this or like that, we tried to have some discussions about, what are the trade-offs here? And also, like, people would argue for or against. So then we need to have some reasoning behind it, right? So should it be like this or should it be like this?
Huh.
And then I started writing them down at some point. I think first maybe it was just like in a private file. And then they sort of made it a little bit into GitHub, and we started discussing. And sometimes there would be a discussion about a feature, and then that would end up being, oh, okay, we actually need to have a principle here. And at some point it made it to the website.
Huh.
And then we started thinking actually that it would be nice if other languages had this too, because now this is a quick way to show what is the language all about.
Right.
And so in the case of
and
Flix,
help settle any debates or like anytime a question comes up of like, what should we do here? You can go back to the principles, and if the principles don't tell you what to do, then it's time to write a new principle, right?
You need a new principle, yes. And sometimes you discover that you've made, maybe a small error, or you need to refine a principle. So that's also happened a little bit.
Yeah, and maybe like at some point principles are in conflict or seem to be in conflict, and then and then you have to revise to try to get rid of the conflict or something.
Yeah, the only time I've ever seen it done was in Python, and again, that was in hindsight. And it does seem like, boy, if you started out with something like this really early in the process, it would just make the language. I would say Kotlin has those principles somewhere, but it's not, I inferred them by the way that the language was designed.
Well, a lot of times I think that the culture contains the principles, but they're not written down.
And I think it's really helpful to have them written down, especially for newcomers.
Yeah.
Yeah, I think so too. And also, like, I won't claim to be designing a language necessarily for everyone and for every single use case. But having them written down, I think you can look at it and see, is this some value in some sense I believe in, right? For example, we have this thing with unused variables. And when I show people the language, they're always kind of upset about it because, why won't it let my program compile? I have an unused variable, but so what, right? But then other people, if you've written a big program and, there's a bug and you stare at the code and you can't find it, and at the end you discover, this variable was unused and had a small typo. It should have been E2 instead of E1 or whatever. Then you suddenly appreciate why this principle is there.
It's an error.
It's an error, yes.
variable should be an error.
And it is.
Yeah.
And that's written down in the principles.
And if you don't like that, you should be a PHP programmer or something.
Maybe PHP is more aligned with your values.
Yeah, that's a better way of putting it. You really did learn something from that NVC class we took.
So, Magnus, thank you for joining us. And I would love to start with just like a little bit of history of the language and what your involvement with it has been. And
what made you say the world needs another programming language, and I'm going to do it right this time?
That's a good question. That's everyone is asked that if they design a language, right? So maybe I'll give you the standard, well-developed answer for that, right? So it's we need new programming languages for the same reasons that we need more efficient airplanes, safer cars, and more ergonomic chairs, right? So we already have chairs. So why do we need new chairs? We already have airplanes. Why are they not good enough? We already have cars. Why can't we just stay with the first cars we developed? Now, I think, in programming languages and programming language design, it takes a lot of time for sort of, the good ideas to be found and make their way into real languages. So, maybe you don't see the development as quickly as if you look at an airplane. And you can also, if you look at an airplane from today and one from, 50 years ago, it's very clear to see the difference. With languages, it's a bit harder to illustrate that. So I think that's my answer for why we need new programming languages.
There's probably an aspect to like productivity. Like we want developers to have better productivity, build better software.
Yes.
And the tools that we use are very integral in that.
Yes. And you could say, on my PhD, I did research on program analysis for JavaScript. And so, JavaScript was sort of, how to say it, perhaps less well designed from the beginning.
Can we even say it was designed?
There are some things.
It was designed like art, where it's just like the art where you just like throw stuff at the wall. I think it was
Jackson Pollock.
Okay, that's the Jackson Pollock of programming languages.
I would again argue that was PHP, but
PHP too. I mean, we've maybe all read the PHP: A Fractal of Bad Design. So I was trying to reason about, JavaScript, right? And so looking at programs, and they're like, buggy programs and has all kinds of disastrous consequences. And then you think about, why is it like this? Like, why does the language permit this, right? And, this bug, could have been prevented if, there was just some simple restrictions on how you're supposed to write your program. And so I think, the challenge of doing that sort of also grew into this idea in my mind that I wanted to design a language that was fairly strict and principled about what you're allowed to do and try to give you some basic guarantees, and that gives you some knowledge about your program.
Yeah. Speaking of JavaScript, I don't know. We probably shouldn't do too much JavaScript bashing.
We can speak about that for hours.
I just saw a tweet that was JavaScript where it was like %, and it starts with like %, 0.5 or something like that, and I don't know, it parses to 0, and then they keep increasing the decimal places, so then it gets to like 0.0.5 and then 0.0.0.5, and when you get, I don't know, 6 decimal places in or something like that, all of a sudden % returns 5 instead of 0. You're like, oh my god, like what is
why?
It? Yeah.
What?
I saw that one. It was just like, okay. I mean, at this point, I'm not even surprised.
Right. Yeah, that's true.
Just like,
yeah,
sure, of course.
Yeah. I think like what I dream of is a programming language that there is no puzzlers session. Like at the conference, like the puzzlers that you get. It's like puzzlers to me indicate that you've done something, like the design has gone wrong.
Yes. You should aim not to have any puzzlers. I think that too.
Yeah.
Mm-hmm.
Yeah.
But some people will argue, right? So with Flix, for example, it's being strict with various things. I'm sure we'll get into details. That it's a hindrance to prototyping, because in JavaScript or Python, you are allowed to do pretty much everything, and the computer is at your command. And I think maybe this is a reasonable argument, but maybe that also means we should separate. I'm writing a prototype in 100 lines of code versus I'm building a huge system for deployment, in some serious application.
Yeah, I guess there's trade-offs there, right? Like it does when you spend a lot of time trying to satisfy the constraints of a stricter programming language, that doesn't always feel like progress, or it feels like it's inhibiting you from the kind of early iterations that you're maybe doing on thinking about structure of a program and data modeling and some of that stuff. So I can kind of
just
get
experimentation, and maybe in some sense, especially if you're a beginner, you just want to run your program, and then in JavaScript it will run, and it will maybe print something.
Yeah. So go ahead, Bruce.
Yeah, that's a question. I've been thinking we should have Guido van Rossum on the podcast, because I've known him for a long time. But one of the questions I want to ask him is like, okay, we have, especially in the functional programming world, we're going, oh man, everything Python does is kind of wrong. And yet it solves so many problems. Yeah, so it's like, I want to deal with what's going on there. It's like it still works for a lot of things. It doesn't work for everything, or I don't know. Or
everything is wrong, but something is still right.
So there's so much that's right about it that people can do amazing things, and it's only when you reach the, I don't know. Sometimes it's performance. Sometimes it's, I don't know. It's like, so how come it still works? How come it still works as well as it does? And then there's this domain of problems where, say maybe you want Rust. It's like, well, we can't have a garbage collector. It's got to be totally fast. And so it's like, oh, well, that's probably what you don't want C++ or C or Go or anything. You want Rust. And then then there's this domain that I think we've all been talking about, which is like, okay, but what if we want rock solid reliability? Every piece has to be reliable, and then we have to have a composition mechanism that allows us to put those pieces together in a reliable fashion. At least that's my thesis about all this.
I mean, there's also this research, and I think people, also just have experience, right? That you would rather find a bug sort of early while developing it than having to, find it, sometime later or even in production, right?
Yeah.
And so the idea that you have sort of, production code running out there with some computations, and then the local variable is not used, for example, maybe it's just kind of concerning.
That's the worst time to find out about a bug.
Well, and it also suggests that you will always be finding bugs. If you can find them in production, then you're always going to be finding them in production.
Yeah.
So how long have you been working on Flix?
So it started with a research project back in 2016, I think, and we are looking more into this functional and logic programming aspect with Datalog. I'm sure we can talk about later.
Yes, definitely.
And so, but when you do research, there's sort of short term, and that's like coming up with an idea, writing a paper, and these kinds of things. But I already knew that I wanted to design a programming language. I just needed to find sort of an excuse and a path. So that's where it really started. And I worked on it for a couple of years in Waterloo. And then I came back to Denmark. I was first at another university, Aalborg University, and then I came to Aarhus University. And so I've been working on it for the last several years. And over time, sort of more people have joined. So I have my PhD student, Jonathan, working on it. And there's people in the open source community. There's some student programmers and so on. So it sort of have been growing slowly that way, very organically, I would say, too.
Huh. And it came across my radar, as I said a few months ago. It seemed like there was, I don't know, more interest all of a sudden. And that's
certainly. I think it was because Runar, you had on earlier, of Unison fame. He
I think that's where I actually heard about
tweeted some kind words. Yeah.
Nice.
Yeah, he said he liked it.
Yeah.
Mm-hmm.
Yes, give us a rundown on like what the state of Flix is, and then we can go into some of the principles.
Sure. Yeah, I can do the sales pitch, or I can tell you
that'd be great.
So we've been working on it for several years. I'll say first that we're trying to build a real language, so that means the design choices we make with the compiler and testing and so on, we take that very seriously. We have 12,000 manually written tests. A compiler project itself, to give you a sense of scope, is like 180,000 lines of code.
Well,
so it's quite
what's
big.
it written
right?
in?
It's written in Scala.
Okay. I think we saw that.
The next best programming language that I know.
I've done a lot of Scala, and Bruce and I and another friend are currently writing a book about Scala 3, and so we like Scala. It's a great language.
Yes, me too. I think it's a great language. You can definitely see the inspiration in Flix.
Yeah.
But it also tries to make some different trade-offs. Talking about the language itself, so it's a functional, imperative, and logic programming language. So basically, having all the paradigms except the object-oriented one, which might be a bit strange. It has a type inference, so it's very much in the family of like Haskell and OCaml. But it's not a functional language like purely functional language in the sense of Haskell, because it does have imperative programming, so you can have mutation and these kinds of things. It doesn't have classes like object-oriented languages. Instead, it has type classes. So in that way, it's like Haskell.
And it has ADTs, so you can only do
algebraic data types, pattern matching, first-class functions. Parametric polymorphism. It has records.
No, wait. What is parametric polymorphism?
That's just generics. That's just when you're an academic, you say it like that.
No, that wasn't the word. That wasn't the one I was looking for. It was actually parametric.
You mean effect polymorphism?
Yeah. I think it was effect polymorphism. Right. That was it. That was the question.
So one of the unique selling points of Flix, I think, as of today, is that it has an effect system that tracks whether an expression is pure or not. And so what does it mean? It approximately means that if something is pure, it's a bit like being in Haskell. So you know that it cannot have any side effects. So what does that mean? It means that it's not going to mutate memory. It also means it's not going to read the system clock or throw a random coin. So that means that expression will evaluate to the same value if given the same inputs, if it's a function, for example. On the other hand, you can also have expressions that are impure, so printing to the console, mutating arrays, and so on. And so the Flix language knows for every expression whether it's pure or not. Now, what about a higher order function? So you have like map, right? You want to map a function over a list. Well, is that pure or not? That depends on the purity of the function you're mapping. So you have a list and you map like something with print, then clearly now the whole thing is impure. If you map like, x goes to x plus 1, then the whole thing is pure.
So the language knows that if you're using a functor that is impure, then the
whole thing is impure.
The whole thing is then impure.
Yes.
Yeah.
So effect polymorphism is just a very fancy way of saying something simple, that sometimes a function that has a function argument, its purity depends on the purity of the function argument.
Huh. That's cool. I think that's the first time I've seen a language that has that concept.
So I think we are one of the first languages to have this, especially to make it a little bit technical, right? So we are in the Hindley-Milner style kind of type system, which means we have full type inference. So to compare to some languages, they have like a kind of partial type inference. So sometimes type inference will fail and you have to put an annotation. But in Flix or OCaml for that matter, well, if there is a type error, it's not because inference fails, it's because your program is somehow wrong. So you need to go and change things. Not add annotation, change things.
Yeah.
And so we have this even with this effect system. So we also, infer these effects without you having to write anything.
Huh.
So you don't actually have to annotate whether something is pure or impure.
You don't. But now we get to this point about the principles not always being exact. So if you look at some Flix code, you might say, what is he talking about with inference? Because I see these signatures. And the signatures are clearly annotations. Mm-hmm. Okay, so let me try to clarify that. So when you write a research paper, and the way the theory works, it could be completely without signatures, like in Haskell. That actually would work. But as a software engineering trade-off, many people like the top-level things, especially things that are exposed to the outside, should have signatures. And so really
APIs,
exactly, as a design choice, we mandate top-level things to have signatures because programmers, at least for me, it's nice to think about, well, what should this function do? So I want to write a signature, and then off I go inside and I write a lot of code.
But could you automate? IntelliJ in Scala will automatically generate the type signatures for you.
In principle, yes, we could do that. We don't have
Okay.
it, but the theory supports this, yes.
So, but you see as the programming process, the programmer should first generate the signature and then the implementation.
I think so, yeah.
Okay.
But notice if you have local functions inside a top-level function, you don't have to write any signatures. So any local function you declare, you can skip this.
Yeah.
Because that doesn't need to be exposed.
Yes. And this is really on the design aspect, not really on the requirements of the type system, because there we could have omitted them entirely. There are also, there are three advantages of the top-level signatures. So the first thing is it's kind of a documentation because it expresses intent.
Yeah.
The second thing is it gives us parallel type checking. Why? Well, because when we type check things, if I have the signature of a function, I don't have to go into it. I just assume the signature to be correct. And then later I know what the body will be compared to the signature, so it's okay. So the type check on Flix is just parallel by default.
That's cool.
And what was the third thing? I forget.
I know, it sounded like a third thing.
There is a third thing. It's on the list. Let me look it up. Yeah.
I really like the way you think about this. It's just so much, because my experience with programming languages is that the designer rapidly gets into the details and they forget about the higher level way, concepts. And I have to go in and figure them out and explain them to the reader.
Right.
And
I found the third thing. So
Yes.
it is that you get better error messages. And the reason is that you assume the signature is correct.
Mhm.
And so, if this function takes a string and an int and you're calling it with, 2 integers, then we blame the caller because it doesn't match the signature. So there's also
if you
software
didn't
engineering.
explicitly say it,
Yeah.
it would infer, you're passing an int and an int, so then the body would probably then be wrong as it tries to use an int.
So then you might get an error not really local to where the problem is, because here we force you at the top level to make it an API in some sense. You have to specify the interface.
Yeah, that makes sense. Yeah, and you do have some principles around error messages and helpfulness of error messages. Tell us more about that.
Was that inspired by Elm?
Oh, definitely. So there are these 2 blog posts, right? What is it?
From Evan.
Yeah, compilers as assistants, I think, and human readable error messages or something like this. So those principles are very inspired by that. But one thing I also read in a paper recently that we started changing a little bit was to not have too negative language. So previous versions of the Flix compiler says illegal something. You did something illegal, so go straight to
Makes you
jail.
feel very shameful about what you've done.
Yes, exactly.
Are the police coming?
Yes.
Right.
So now we just try to explain it more, I think, as the paper suggests, a little bit more sort of from the program's point of view. Like, these are the things I see.
I expected this and didn't get that.
And I was unable to figure this out, right?
Right. Yeah.
Maybe because of the limitation.
It's like the compiler takes the blame. It's like, sorry, I don't understand what you're trying to do here.
See, once again, it's the influence of nonviolent communication.
That's right. Nonviolent compilers.
Yes.
That's awesome.
And then we have some other principles, like, someone pointed out also, I forget who it was, that, in many cases, maybe 80% of the time, you just need to see a few words of the error message because you've seen it before. So when you're programming, you're familiar with error messages over time. You get to know them and the structures. You just need to see a few words and you can figure out what's wrong. But then there's the other case where you've never seen this error message before, and now you need a lot of more information. So you have to sort of satisfy both use cases. And so we try to give a one-line summary first that you can scan quickly, and ideally from left to right. And then after, we get more verbose about what's wrong. That's what we're trying to do.
The worst experience that I ever had with error messages was in the early days of C++ when they were just adding generics. And if you did something wrong, it would give you pages of incomprehensible gobbledygook, and you could not.
Very precise.
Useful. It was totally useless. It was and really frustrating. So I think this is really important.
And I think all languages have done a lot here. And, maybe it's based on these blog posts, but also sort of just as a, you couldn't get away with making a modern language today, I think, and just give sort of one-line garbled messages, or as you say in the other case in C++, emitting hundreds and hundreds of lines of internal stuff.
Yeah, and I think like a lot of what's happened in this area is trying to make the error messages, the compiler messages, helpful for the user, like telling them what they can do to fix it.
Yeah.
And I think Rust is really done a good job of this.
Yeah.
It's like the compiler's like, yeah, I can figure this out, and here's what you should probably try.
Yes.
And it gives you some suggestions, and yeah, and you even say that in your principles, that including suggestions for how to correct the problem. Yeah.
That's so nice.
Yes. So I mean, you can take this far, right? You could try even for these program repair techniques where you try to guess, but at least you also have a principle like if we don't know what to say, we can maybe say how it's different from other languages, or we could say what a common problem is.
Yeah.
So maybe you're encountering this common problem, and this is what you should try to do.
Yeah. Yeah. So for some of the other principles, there's so much that I'm just like 100%. This is just so much better. Like no null value. Like it just doesn't seem possible to me to create a language today that has anything like null. That just would be wrong. No reflection. I'm so on board with no reflection. Just reflection is just such a recipe for production runtime bugs that things happen
framework
in a different
effect,
way.
Right? So it's like instead of programming in Java, I want to program in a combination of annotations and XML, and then that's enabled by reflection.
Yep. Yeah.
But then when things go wrong,
how do you know where? Why?
Yeah. Then it's like programming in PHP again.
Yeah. What's interesting is on the Spring side of things, they're now focusing a lot on doing ahead of time compilation to get rid of reflection.
Okay.
And it's like, okay, even the Spring folks are trying to move away from reflection.
So let me ask a question. So you built this on top of the JVM, which I would think make the process of creating a new language way easier, because then you don't have to worry about all the stuff that the JVM does. But one thing that's been occurring to me is that the JVM was built for Java and Java constraints. Is it time for us as the programming world to build a new VM that isn't just for Java? It's like, especially when we're talking about functional programming, it seems like if we had a VM that worked also.
Yes, please. I'm glad you asked this question. It's been time for 10 years, right?
Yeah.
So, where are my tail calls, right? Where are my continuation support?
Yeah.
Or immutability,
immutability, all these things, right?
Yeah.
Even ownership, for example.
Mm-hmm.
The VM knew about that. There are things that could be done, perhaps. And it's like 10 years over time. There's WebAssembly, but WebAssembly, as of today, right, doesn't have tail calls. The garbage collection store is also a work in progress. I don't know what the status.
I was going to mention WebAssembly as being one of the possible places where this could happen, but there's still quite a few gaps there that, they're still working out the ability to do to talk from WebAssembly WASM to JavaScript. Like the interop there is not quite there. Like doing a garbage collector is still a work in progress. There's a number of places that WASM I think is still has a long ways to go, but maybe the thing that in 5 years or so that we could actually.
I think there's really space for a new virtual machine. I mean, I don't know who would pay to develop it, because I think it's a huge undertaking, but certainly many also of the ideas that are coming up in newer programming languages really do need some kind of better runtime support, and they have to emulate it today at performance costs.
Well, and I guess wasn't LLVM originally intended to be that new virtual machine?
Yes.
Okay, and it just became a high-level assembly language for the. You mentioned tail call elimination, and that confused me a little bit because you made a big deal about it on your webpage. By the way, we should tell everybody flix.dev if you want to kind of go follow along while we're talking about this. I mean, Scala and Kotlin both provide tail call elimination, don't they?
That's the playground version or the toy version. So we need to distinguish between two things, right? So, and it can actually be shown with a simple example. So a function that calls itself recursively, tail
Yes.
call position. Scala and many languages can deal with this, and that's fine. But for serious programming, you want the ability to tail call a different function, and the stack shouldn't grow. So a toy example is if you write a function even and a function odd, and then they tail call each other.
Right.
So the stack looks like odd,
So even
odd.
with two functions,
And
you
then that
you can't do the tail call elimination.
Yeah.
So this is like the many body problem in physics.
yeah, possibly, I don't know. So in those languages, that doesn't get they don't do anything about that. So you blow the stack, and that's also why in Scala some of the functional libraries have sort of explicit functions. Like there's the Scala cats library, maybe you've heard about,
Yeah.
where you have to sort of really care about not blowing the stack. And so in Flix, the way we deal with that is that we pay a cost. So we have to emulate calls with trampolines. And so that just makes us a few factors slower. But on the other hand, you can't get a Stack Overflow error if your call is in tail position.
Okay. And do you have to, I mean, like, I know with Kotlin, you have to use a keyword tail rec to tell it to eliminate
No,
tail
that would
calls.
be, I should be careful, but that would be ugly, right? Then
Well,
you would
it
have
is. You really have to think about it when
It's like
you're
the
writing.
compiler should know, right? The compiler should.
The compiler should know, right? I mean, maybe there could be an annotation just to, if you have this intention, you could express that intention, have it checked.
Mhm.
But if it's a tail call in Flix, it's a tail call, and then that's it, right?
And so you never have to tell it. It just does it.
No. Yeah, it does it.
Well, that does sound nice. But to do that, you have to constrain something in the language.
Now, I don't have to constrain anything, but I have to pay a runtime performance cost because I can't use just Java stack. I have to do some emulation of the stack myself.
So could Scala and Kotlin do that if they... Okay.
We're willing to, but it's probably a slowdown of like 2 or 3x. So that's probably unacceptable to these languages.
I see.
But
But one of your values is to value. Let's find it.
Correctness
over performance. So back to those.
do you want your program to crash when someone puts too many items in the shopping list, or I don't know, whatever, right?
Right.
Yeah, whatever would maybe cause a Stack Overflow.
Yeah, and it's like one of the things that you're way too young to remember this, but you may have come across the concept of the software crisis, which the idea started happening in the 60s and 70s. And when I was initially coming on, that was the big deal. It's like, oh, we have the software crisis. And the deal was that we need to be able to create programs faster. And they paid lip service to reliability, of course, because otherwise you create programs quickly that are broken. But in the end, it was more about the business need for more software faster and not the reliability. We compromised on that. And I think when you have your maxim that no, reliability is the most important thing, it's like, of course it is.
Yeah, I think so too. It's just so annoying when software isn't reliable. I mean, every day, right?
Of
course.
You
turn on the oven or something and it doesn't work.
Everywhere. And this is the foundation of our book, which is like, creating reliable software is job one, not just creating software quickly.
Yeah. Everyone can write fast algorithms when they're wrong.
Mm-hmm.
That's right. Could be highly productive at creating software that is terribly buggy.
And we are.
Yeah.
We are.
There's some other great principles here. Legal state should be unrepresentable. That's something that is
that's something to aspire to, right? It's difficult.
I see this. It's marked as
modeling.
In progress. So why is that one in progress?
So that's because I think it gives an example that Ada has, I think, where instead of having integers, you just say, well, this is an age, and an age, a person is between 0 and 150 years old. So instead of just using 32-bit integers everywhere, you try to be more precise. And so I think we also wanted to have some of that stuff.
I see. Yep. And this is like the what's the word for that I'm thinking of? Being able to constrain your data types to a given set of values, and validate
There's something
that at
called
compile
refinement
time.
types
Refinement
that goes
types,
in this direction. We don't have it, but that's something we're interested in too.
Nice. So
I just
maybe one comment about the type inference, right? So we talked about it a little bit before, but also going back to this thing with now maybe the pendulum has to swing in the other direction towards maintainability and quality. But on the other hand, the JavaScript framework de jure, right? It's like that's upvoted on Hacker News, and so it's hard to see, right? All this good research being done on type systems and so on, all these ideas, and we are moving in the other direction, right? We were moving towards Java for some time, which had the type system, and now we are moving away from it. And so also a design goal of Flix, which is perhaps not explicitly stated, but is that we need to get the type systems back, but clearly they have to have type inference.
Yeah.
We really have to be focused on the type inference so we can make the argument to JavaScript programmers and so on that you don't have to type anything extra or very, very little, and then you get a lot of guarantees for free and refactoring and all these things you can do.
This is where when I see or participate in debates around type systems, the people that are against them are usually against Java type systems. Like they haven't experienced a type system with type inference, and I think that's a huge thing that will open up the doors for a lot of people back into the world of type systems is type inference, good type inference.
I think my problem with them in the past has been that you do a lot of work and you don't get that much of a benefit. Whereas when you have a good type system and it really solves a lot of problems for you, you go, oh, well, obviously that's great. And I think whereas the Java type system was like,
are you serving the type system or is it serving you?
Yeah, it's kind of like semicolons. What are they for? They're for the compiler writer. They're not for the programmer.
Was Flix the language I looked at recently that did have semicolons, like required?
So we have semicolons because there is an ambiguity issue I don't know how to resolve. And there's these JavaScript memes and other things that also show it, where if you have full semicolon inference, it's possible to write programs that their meaning changes if you insert a line break, for example. And inserting a line break and changing the meaning seems really dangerous. Also think about reviewing a pull request and these kinds of things. Because then you basically have a form of significant white space too, suddenly.
Right.
So Flix has semicolons. I think we can drop them in certain places. So I think a long-term goal will be to try to do that. But I will not want to do it at the cost of introducing these puzzlers.
Yeah. Yep. That makes sense.
Yeah, because in your examples, I see them someplace, but not everywhere.
They separate statements, right? So you want to have two print statements, you need them. You need them after let binding, and that's pretty much it.
And then is there some place where you're using periods?
Yeah, that's in the logic fragment only.
Oh, I want to get into the data log stuff.
Yes.
But before we get there, a couple more principles. No warnings, only errors. I love that. It's like
Because what about the warnings? Then I also educate.
Too easy to ignore.
And then they are ignored or they're confusing, or some people consider warnings to be errors, or some of the warnings are errors. So I think the nice thing about this principle, and this is something Go actually got right, I think they also only have errors, is that it means the language designer has to really put their foot down and say, this is not okay. Or alternatively, this is like totally okay. Not we're a little bit concerned about it. So maybe you just say something, right?
Yeah, warnings are confusing.
Yeah.
Yeah.
You don't know what to do about them. Is this important
Scala,
or it isn't?
I'm sure that you have your Scala code base for the compiler set to make all warnings to errors, and that's
the build system.
Yeah, and that's a key thing I think for. I can't think of like a real Scala project that shouldn't have that enabled. And I actually in Kotlin you can do the same thing. So I've done that in my Kotlin project.
So, one thing
what's
that
sad
came
is
up,
it's not the defaults in Kotlin and Scala, whereas it's
right.
Just make it the default.
Someone was saying that what about deprecation warnings? Are they warnings or errors? So this shows that things are not as clear cut. So I had to introduce sort of a mental category called, what do we call them? Like code hints, using the Visual Studio Code terminology. So a deprecation thing is a code hint, right? So it's some meta information about the program. It's not an error to call a function that's scheduled for removal. And it's not a warning because we don't have warnings.
Right.
So
it's just is a it's
it is
just a heads up. It's like,
Yeah.
hey, heads up, this thing is going to go
Yes.
away.
Yes.
Well, it's just a
It's an
deprecation.
IDE tip, right? It shows up
Yeah.
in the IDE.
Yeah, maybe it's just a completely different category.
Yeah, I think so.
Why should there only be 2 categories?
Yeah.
Right.
Mm-hmm.
Exhaustive pattern matching, ADT is like so much good stuff in here that I've just become the standard way that I build software now. Expression oriented, that relates to kind of the semicolon topic a little bit. And yeah, I mean, again, like there's just so much stuff in here. I'm like modern languages that aren't expression oriented. It's like, what are you even doing? You know, it's just like, that's just the way things should be.
Yeah, once you see it, it's hard. You can't unsee it. And then everywhere you look, you're going, why? What? Didn't you know about this when you were designing the language? Why?
And it
no
also-
var args. I'd never heard the term variadic. I think for var args, that
variadic argument list.
But I liked your thing there. It says like it's not clear how you could have a language that supports both currying and variadic functions cleanly. And I was like, absolutely, that is never resolved. So let's just not have var args. And if you have a concise syntax for constructing a list, then you don't need it anyway. So
yeah.
Mm-hmm.
That was good. No labeled function arguments. That one was interesting. And it's something I've actually talked to John DeGoes about a bit, like design wise, could you do that? And I think that's one that I'm gonna have to like play with and see like how that all feels.
So what does it say? Because I think so it doesn't
Flix
have
does
them,
not
right?
support labeled function arguments. The motivation for labeled arguments is reasonable to avoid calling a function with arguments of the same type, but in the wrong order. Unfortunately, labeled function arguments do not work in the presence of higher order functions. Mm-hmm. Instead, we suggest to overcome the problem by either using richer types, like using Celsius instead of int, or alternatively using record types, which can be used to emulate the same functionality and works with higher order functions. So
there's a new principle. You can be the first to hear about it. So let's break it down. So first of all, the label thing in many languages is sort of something that's bolted on, so it only works for like top level things, and sometimes they're extremely complicated rules. So is it Python where you have like labeled arguments and var args, and you can also put a comma in between, and then some has to be positional and some has to be labeled?
Well, and it has default arguments too.
So
it allows you
to
have a lot of arguments, and they all have defaults, and then you only have to say the one that you want to change.
Or you could do this in
so you can have like a PhD in the in the arguments for functions. So what we wanted to do, that this principle already captures, is that you can use a record, right? And then, a smart compiler, hopefully, we don't do it yet, but, nothing prevents it from optimizing that away. But one thing we started doing recently, we fixed it in entire standard library, is that if there are functions in the standard library where you could swap the order of arguments, so for example, string replace is a good example. It takes 2 strings, right? But which one is the substring and which one is the target?
Yep.
The first argument, last argument. And especially if you're learning a language, like which one is it? Now, the thing is with label arguments is that then that resolves it, because you write out the label. That's fine. Now we can use 2 records, and then we force you to write out the labels also. So then it's good, because you can see it, right?
It's just another way to do labeled arguments.
But
then there's some verbosity that you get in exchange for that. So it's like positional gives us a more concise syntax, but then there's some implicit order that you have to understand.
Yes. But two twists on this thing. So the first is that label arguments can't force the caller to write out the arguments. But using records, as we do, forces the caller to write it out, which means that when you implement string replace, we have decided that everyone who calls this must write the arguments out. So now we know throughout the entire code base that the labels will be there, right? Because you have to write them.
Yeah,
that's one thing.
So you as a API designer for a library, you get to decide when the user must use labeled argument.
Kind of quote unquote a labeled argument.
Yeah.
The second thing is
That
we
makes
introduce
sense. And
syntactic
it's only like so the person writing the function, they're going to know that there's going to be some ambiguity with the usage of their function. And so they're saying I know that there is ambiguity here. You must now label these things.
Yes. And now we know that all the callers will spell it out. Yeah. Second thing, we have syntactic sugar that just allows you in a call to write, substring equal a string, and then that becomes a record. And there's no ambiguity issue here. So it looks like actually a call.
Yeah.
But now it works because it's part of the type system. It's a record. So it works with, first-class functions and all these things.
Yeah.
The last strange thing, and this is unique to Flix, so using records for this, other languages have played with that, is that if you take string replace and you remake both into records, then it doesn't work with pipelines anymore. So let's say you wanted to say, have a list and you do a map and you say, want to replace,
Yeah.
So actually what we do is that we only require the first arguments to be records. And then the last argument stays as a string.
Huh.
So this way you have the signature is something like a record called, substring, and then a record called replacement or whatever, I forget. And then the string argument itself.
Yeah. Huh.
So you have to see it a little bit in front of you.
Yeah.
But, this means that you cannot swap the order because one is a record and one is a string. Those are not type compatible.
Yeah.
But it still works with pipelines.
Huh. Yeah, I think this is one place of Flix that I really need to play with, and it sounds like you've tackled some of the challenges with the trade-offs between ordering and labeling.
So now claim you cannot mess up the order of any function in the standard library.
Yeah, that's awesome.
So 2 kind of basic questions. Is it ready for prime time? And what's the Java interoperability story?
Yeah, good questions. I think as of sort of summer last year, it's ready to be used for, seriously. We have a lot of tests. There's the website, there's the documentation, there's API documentation like JavaDoc. There's a Visual Studio Code plugin. And the nice thing about the Visual Studio Code plugin, by the way, is that it uses the real compiler. So I've been experimenting with all languages where there seems to be this, I'm not sure exactly why, maybe it's engineering issues, but there's the real compiler and then there's the plugin. And sometimes they don't agree. And this can be really annoying.
Really annoying. Yeah.
Now, of course, there's some limitations, but, how well does it work with programs that, has syntax errors and so on? But if you get a type error, you will always get a type error by running the real compiler because it's the same code base.
You never have an ambiguity between red squigglies in your IDE and the reality of the compiler.
Those things are always the same. So I think that's very good. Yeah. And we are using it ourselves. I know of one industry user, they wish to say anonymous, but they're using it for some data analytics. So yeah, I think people should try it out, and they have been. And they don't seem to run into errors. I think they lose interest, unfortunately, maybe before they crash the compiler, but I think that's a sign of quality also.
Nice. Okay, and then Java interop?
Java interop, yeah. So that would be the reason it's not ready for prime time, perhaps. Right? So the tricky thing here is that, first of all, there's Scala, which is an excellent language for Java interop and some functional programming. And so you should really use that if Java interop is really important. What we can do is that we can call out to Java code. And that means, if you want to reuse the file API and so on, you can get away with it. Now, what becomes tricky is that what if you have to extend some Java class? But you can't do that because we don't have classes. So then you might write a little bit of Java code for interop. But I mean, you can bundle jars and you can access them, and you just write the methods like you would call them, and they become sort of Flix signatures.
Yeah. I'm sure with some of your principles, there's some challenges with interop because like nullability, like how do you know, essentially you just have to assume that everything in Java is nullable. So so that gets so then you wrap it all in option or whatever. And then similarly with purity, it's like, how do you know if something is pure or not on the Java side? You don't, and so you just have to assume that everything is impure.
Yes. So there, right, in Scala, the interop is extremely good, I would say, right? It's really the same language in some sense. Yeah. And in Flix, it's not that like that. In Flix, it's more like you import things. And when you import a Java method that you would like to call, you say whether it's pure or not.
Oh, okay.
You deal with whether I can return null or not.
You tell the user.
So you have to annotate that information. But if you do that correctly, then you have all the guarantees.
Cool. Okay, so now I want to go into data log stuff because this Bruce and I, when we first started looking at a Flix, I had to look up what the data log stuff is because it was a totally new concept to me. So give us the rundown on the data log piece.
Yeah.
And assume I know nothing because I know nothing.
Yeah. So data log is a logic programming language, which means that you write constraints, and then when you run a data log program, the compiler and runtime somehow solves these constraints and give you a solution. Now, what are these kinds of constraints? They are closest to SQL, I think. You can almost think of them as SQL, but with recursion. So in SQL, it's like, you have some tables and you join them. So you join like the user table with the post table, and then you filter a little bit, and then you get a result table out. Now in data log, you also write queries like this. Syntax is a little bit different. But then you can sort of take the result, which is a table, and you could insert those rows into another table. And then you can iterate this process. And so the recursion means that, for example, if you wanted to find, like, is there a path from, I don't know, Rome to Paris? You have a graph, then you can write a 2-line data log program that will, discover such a path or enumerate such a path. So that's data log in isolation. I have a few more things about data log. So one is that any data log program, like most SQL queries, if you behave nice, terminate. So, you always get a result, right? It's nice if you write simple SQL queries. It's always a result for you. Maybe not the one you want, but you always get something to look at. There are efficient techniques to solve these things. So as a query language, it's really good. You can do it in parallel, all kinds of things. Okay, fine. So then you could say, well, we should all program in data log. And maybe at some point, that's what people thought. But it turns out that, programming is not really just querying some tables. I mean, we're not writing all our programs in SQL. We need the ability to express other things. Okay, so then the story sort of before Flix, you could say, was, well, I write my Java program, let's say a Scala program. Then I write a data log program that I generate as a string. That's also how we use SQL today in some places.
Just send the string over to the database and let it deal with it.
Send it over. Get the result back, and then you need to process the result, the types, and so on.
Yeah.
And then, that's how it works. So Flix, then, what it does is that it just has this data log language embedded in it, tied to its type system. So you can certainly say, okay, now I want to implement a function. Say, can I go from Paris to Rome? So I'm going to write a little logic program here, and then I'm going to solve it. Maybe you only want a Boolean out. Maybe you want the path out. I don't know. Then you extract that with a query mechanism, a little bit like LINQ.
Yep.
So you write the logic fragment, and then you have something like LINQ to extract the things you care about. And then that could be the implementation of a function. And seen from the outside, you wouldn't know that.
So how similar is Datalog to like Prolog?
Yeah. So both are logic programming languages, and syntactically, they look the same.
Oh.
So it's a bit like, like Scheme and Racket, and these languages look the same. But they are very different in the sense that Prolog is an almost imperative language, because in Prolog, order of statements matter. There are concerns about backtracking. You can write programs that loop. So Datalog is the more friendly version that can't compute everything. But on the other hand, it's much more... you don't have to worry too much about how you write your programs. The order of your constraints does not matter. It's just a bunch of constraints.
And they do in Prolog? The order matters?
Yeah, because Prolog is searching through a space, possibly infinite, and so it's important to go through the rules in a certain order and things like this.
For efficiency.
Well, also you just have to, because if you swap two rules, it could change the meaning of the program.
Oh.
But that's not the case in Datalog.
I see. Well, so I never could understand Prolog. Back when we were having the AI revolution in the 90s.
Right.
I couldn't wrap my head around it, so maybe I could actually understand Datalog.
I think Datalog is a very nice place to start, because I think you get a lot of the power, even though Prolog can do more, right? So Prolog can express any computation. That's not true for Datalog or for plain SQL.
Right.
But Flix is also really saying, I think, that logic programming is a niche, and it's probably not going to take over programming. But it's a niche that could be very useful for certain things, again, like your database query language.
It's sort of like a domain-specific language then?
Yeah.
Okay.
For logic or queries queries
You
as
can
being like a
express everything you
subset
can
of
do in
logic.
SQL, right? But more, because you can do this recursion also.
So I
is
think
the idea that you wouldn't ever have to use SQL? You would just do everything through Datalog?
That's a good question. So it really depends on what you're doing, right? Because SQL is usually because you care about storing your data in a database so you can retrieve it later and asset properties and all these things. But if for some reason you just wanted to do a computation, like load in a big social network graph, compute whatever you compute on a social network graph, yeah, then you can do it just in plain Datalog.
so. I think where this is starting to click for me is I really don't like SQL because, like you're saying, when I do SQL in a program, I've got just this string blob that is totally disconnected from my type system, from any program verification validation that I'm able to do in my type language. I'm just shipping a string over to the database, and it just seems like a place where things can go terribly wrong, and then I have to map the results back, and that
Yes.
mapping, things can go wrong. And so what I have used a lot more is Quill. You may be familiar with Quill. We had one of the maintainers of it on an episode a while back. But it's this language in Scala, or a tool in Scala, that you write monadic transforms like you would in Spark on data, and then it creates the SQL for you that then gets sent over to the database. But then it can manage the mapping and all that stuff for you. So it allows you to write in the type language in the queries, and so I like that part of it. But I think for most people, they don't want to write like monadic Scala transforms to create their queries, and that if they could use if they could use a DSL in their language and not have those impedance mismatches and not be shipping strings, then this would allow you to have people that can focus more on the query side, and other people that focus more on the application logic side.
And
or
it's
whatever.
really more than a DSL, right? Because when I work with a DSL in any language, then let's say it's Java, Scala, then it's a library, right, that had to work with the constraints of Scala, which can admittedly be good, right, but still error messages and so on. This is part of the language, so it's integrated into the type system itself. It's integrated into lexical scope. These things are values and so on. It works with inference, full inference, so you can never have a type error unless actually you're trying to do something that's nonsensical. So the experience should be much better. That's the hope, at least.
Yeah, there's a maxim in the Zen of Python that says practicality beats purity every time. Not the kind of purity you're talking about.
Right.
The pure keyword. It's just, So I have a question about, like, what wouldn't you use Flix for? What is Flix an inappropriate language to solve?
Yeah, I guess there are two things, right? So what would be inappropriate for today, and what would be inappropriate sort of long term, right? But I think let's say you want to do web programming on the front end. I don't think we have any story for that. Let's say you want to write a UI using Swing or something. I don't think there's anything for that. But if you want to write, server applications, data processing, these kinds of things, I think that would be good for. If you want to write an Android application, I don't know if that could work, because I don't know if the bytecode we compile is compatible. If you have heavy dependencies on, you talked about Spring, right, relying on reflection, that's probably a bad match. But if you're writing a microservice, well, we don't have a web server yet, but someone could quickly write one, or maybe reuse one from Java that has a nice API. Yeah, you can do it.
What was the motivation with the Datalog piece?
That came out of pure research, I think. That's where we started. So it was, Datalog is, it's, in our view, right, really more powerful than SQL. It's much more elegant. And we were using Datalog for some program analysis and these kinds of things, but we were also using it in the string way. One program that wraps another program by manipulating strings. This is very unsatisfactory. Yeah. So we wanted to embed it in a functional language so that we can write functional code. That's what we like to do. I think in Flix you would want to use it if you want to write, 80% functional code. Then 5%, 2% Datalog, where it's useful, you take it out, and then some impure code around the edges, because you have to suck in a file, you do your functional thing, then there are some side effects. You write it back to a file, answer requests over the network, or so on.
Yeah. It seemed like Link really charted some uncharted territory in this realm, but you don't really hear much about Link anymore, and I don't know exactly why that like didn't catch on more, but I'm very fascinated in this idea of like embedded query language, which I know that's not all the that's not the full picture of what you can do here, but getting us away from embedding strings for our queries seems like a huge step forward. So that's cool. I want to play with that now, with especially that query piece, and be fun. But what else, Bruce?
Well, you're in academia, and do you teach classes?
Yeah.
Okay. So I'm looking at this language versus what we're doing with Scala and Zio, where I'm finding the learning curve to be really significant. And then I'm looking at your language where it's like you just kind of lay everything out. And I'm thinking, I wonder if this wouldn't be a good language for someone to learn what functional programming is. Do you have
I think
thoughts?
so. No, I really think so. And if I had, the power, or maybe the guts, I would also do that. Sometimes, we have the discussion and say, like, how would we explain this feature to a really good first-year student? Right? This is like the level. There was also this principle of a layered language, right? So, what was it we were joking about the other day, right? So you have like a list of integers and you want to sum it, compute the sum of the elements. Well, so, you could say like, I have like a monoid over the integers, right? And then I can like fold it with, so that works. And you can actually do that in Flix. But even though we have like functor and traversable and all these, we also have a list namespace. And in the list namespace, you will find something called sum. And the signature of list.sum says, give me a list of int32s. I give you an int32 back. There's also a list map that says, give me a function from A to B. Well, with effect EF, because this language tracks effects. Then I give you back a list B, right? So actually, in that way, we try to layer the language by saying there are these type classes, but you don't have to know about them from the beginning. If you just want to work with a list, you can do that. And then that machinery is kind of hidden from you. There are a few things that can never be hidden, but I think you would also recognize that it can't be. So equality, for example. So this equality is something you need to talk about if you have a set, right? You need to have some notion of equality. Yeah. But I think most people can deal with that.
Do you use like strict equality, like a type class based equality?
Yeah, so there's a type class called EQ, and
wonderful.
You can get it derived for free, or you can implement it yourself.
Wonderful.
That sounds, I think that's one of the reasons that Python is so accessible, is because you can do very sophisticated things with it. But if you want to just introduce, hello world, you say print hello world, and boom, you're done. And that, I think that's one of the problems that I've been having with functional languages is they go, first you need to understand functors and monoids and monads. And it's like, but I don't know why.
Right.
I don't know, and it's like, how do I, or even, the number of times that I've, encountered tutorials that say, well, first we're going to understand recursion. And it's like, why? And now I finally understand it after, seeing these things for decades. And I go, I see why. But you shouldn't have to know that to get started. But the people who are creating these languages are so smart that they can't imagine somebody not understanding these concepts. It's, the curse of knowledge squared.
Yes, I see what you mean. I think it's a good point, yeah. And I think we've tried to avoid that a little bit by having this layered approach. One other principle I could mention was, this was something also that came to me just as an idea. So we have like a type error in a specific case. We get this type error, and then it says like something, it's hard to understand, right? Like, this signature is not, this is more general than this signature or something like that. But then it occurred to me, well, we can actually pattern match on the error in the compiler and say, well, actually you have a pure function, but you declared it as impure. And so sometimes now we have like a list, we have several error messages where we try to pick a more specific one. You could say there was no need to do this because we already have an error message that explains everything. But we sort of split up the error messages. So there is still a general one when we simply don't know what is wrong. And it says something scary like, this type cannot be generalized to this type. And then it gives some information. But if it's one of the more simpler errors, it will say, well, this function, you said it was impure, but it's actually pure. That doesn't. That's the problem.
Yeah. Yeah, kind of layering the error messages and
so also
giving the user the most specific.
So even though there is,
the most specific one. Yeah.
So try to generate more specific ones when we can.
Yeah. Nice. That's awesome. Well, I love it, and Bruce, we definitely need to do a little hackathon. I'm encouraged to be at some time with Flix. It's going to be fun to explore for sure.
Yeah. I'm intrigued.
Yeah, there's just a lot of good stuff in there. I want to end with your FAQ. It is the best programming language FAQ ever, and I was laughing out loud many times reading it. So there's just like, as an example, I was disappointed to learn that Flix has feature X instead of my favorite feature Y. And your answer to that one is, we are deeply sorry to have let you down. I like this one. This is by far the worst syntax I've ever seen in a functional language. Semicolons, braces, symbolic soup. It's all. It is like if Scala, Java, and Haskell had a one-night stand in the center of Chernobyl. And then your answer. Quite an achievement, wouldn't you say? Just love it.
Yeah. At some point, you have to say, yeah, this is what we do. And again, going back to Python, Python's philosophy has always been, hey, we're not trying to get you to use our language. If it doesn't work for you, to use something else.
Yeah.
And it never expected to be the number one programming language in the world. That wasn't their goal. Their goal
just
was
do their own thing. I can respect that. Yeah, I think that's a good.
Yeah. And I love that. It's like, I guess at first arguing about programming languages and features when you're younger, that is pretty exciting. But at some point, you get to the place where you go, hey, I've done this. It's a huge waste of time. It's like, yeah, I really appreciate the just going, yeah, sorry that doesn't work for you. Sorry.
Come back when you're more wise.
You should use something else. Absolutely, you should use something else if it doesn't work for you.
Do you ever imagine having the Flix compiler written in Flix?
Yes. That's a question everyone asks. Someday, it's not a priority, but sure, someday we should definitely do it.
We talked
the Flix standard library is written
Richard
in Flix.
Feldman. Yeah.
We talked to Richard Feldman, who's building this language called Rock, and he made it very clear they do not intend for Rock to be self-hosted. And we went into that, and it was fascinating that he just doesn't intend.
Was it Rust?
Rust, yeah, the compiler for Rock is written in Rust.
Which I
don't think it's too
I don't
important.
intend Rock to be a good language for compilers. We're like,
I see.
Okay, I can respect that.
Yeah.
Right. No,
I have one question for you here at the end.
Yeah.
So, what do you think it takes for a language to be successful? Or, what would you do if you were designing a language?
Oh, that's a good question.
A lot of the things that you've done, I would say, but one of the things, I resisted Rust for a long time. I've never written a Rust program, but we investigated it during one of these developer retreats. And one of the things that we came across was the Rust documentation / Rust book is amazingly good. And it just puts all other documentation to shame. And it's like, wow, because that's the onboarding process, well, to give a little background, one of the things that happens at the Python conference is they have a few hackathon days afterwards. And when I first started doing it, I just would go into a project that I knew nothing about, and I would say, okay, I'll work on your onboarding process. What do people... And the developers were like all universally like thrilled because they don't want to do that. And I kind of think that to make a language really successful, you really do have to think a lot about the onboarding process and one of the arguments that I'm kind of in the middle of with the Zio people is, if I don't know if you've looked at Zio, but
I have, but
you have. Okay,
I need to
well,
learn more. Yeah, and how?
the arguments, the type parameters for the Zio object are random letters, and you're
Yeah.
supposed to mentally map those to what they really are. And I'm arguing, don't do that because you're adding cognitive load, but it doesn't make sense to them because they're so used to it
Right.
that they just go, oh, well, just learn the random letters and use those. And it's driving me nuts. So and it's all those little details to say, I guess maybe the thing is, if you start teaching it because when I was teaching both C++ and Java, I would go, oh, I've done a really good job here in the explanation. And then I'd get up and I'd start teaching it, and I'd see these blank stares. And you can't argue with the blank stares. People do, but you can't. And then you go, oh, I need to rewrite that. And so that process of going over and over again, trying it again to develop your whatever your onboarding process is, and exposing it and testing it, I'd say that would probably be the biggest thing, especially these days, because you can't really force a language on people. You have to attract people to your language. So that would be my thing.
Yeah.
Onboarding.
Yeah, that's great. I think so many people do a really horrible job of onboarding
because that's not the interesting part to them.
Yeah.
And you have to actually be interested in bringing users, what is the experience of somebody encountering my language for the first time? And I think you've done a good job, like with your web pages, but the actual tutorial process of learning the language is something that needs a lot of attention, and it takes a lot of work.
Yeah.
Yep, for sure.
Yeah, I think for me, the thing I think about with this is you have to in some way be able to get people from where they are to where you are, and one of the ways to do that is interoperability, and you can see how Scala and Kotlin have gone that route. And I think that the challenge with that, with interoperability, is that it imposes a lot of constraints on what you can do. And so if you really want to change things and make things better, then it's just a trade-off where you no longer have that like smooth bridge that people can walk on to get incrementally from where they are to you. And so what can you do to create a bridge from where people are to where they to you, make that as smooth as possible? And I think maybe, like Bruce is saying, onboarding is a big part of that, or I don't know whether other things would make sense for Flix in that case, but I think that's going to be one of your challenges. And I think part of it is that maybe you get some quicker success with better interoperability, but if you're looking at Flix 20 years from now, that interoperability may not be in the long run as valuable.
We're right. Look at C++. Its success came from backwards compatibility with C, but its burden, its albatross, is backwards compatibility. People go, oh, it was terribly designed. And it's like, no, it wasn't. It was designed for backwards compatibility so people could adopt it. But now it looks like a terrible design.
Yeah.
And so, you don't want to compromise that. You got to have your big vision of what you want it to do. And if interoperability is going to corrupt your language, I wouldn't do it. So there is one thing that I've noticed now with, YouTube. Anybody can create a video, and they can think that they're being very clear because they don't have that immediate feedback of doing it in front of an audience. So I think, and I mean, unfortunately, I see this in the Zio community a lot. It's like, well, obviously you understand this and this and this. It's like there's no feedback, no blank stares to find out that no, your audience doesn't understand it. And so, but again, you're in a position where you could do that.
Yeah, and in fact, we use it a little bit for like there's an elective course where they learn the data log part, and that's where I've been. And then also when they see error messages, and you're like, oh, this is really, it's humbling. Actually, it's humbling because you see the kind of issues you need to think about.
Exactly. It's and the humbling is like, oh, this isn't fun. I mean, for me, it's like, oh, I've done something wrong, and it's like I have to go through a whole emotional cycle with that. But then when you come back and you go, oh, it's so much better now, then it compensates.
But it can also be amazing at the end because then they will have written some programs by themselves.
Yes.
And then they think nothing of it. Like, yeah, I did that.
Yeah. Yeah. And so having your feet on the ground, direct contact with the people who are trying to absorb this material. I mean, even in workshops where that's happened, I've seen people kind of ignore the feedback from the audience and say, oh, well, this is obvious. And the audience is like, well, I have to nod because, I mean, otherwise I'll look stupid. And so you have to make it okay to not understand things. Otherwise you won't get the feedback.
What was your quote from Stack Overflow last night? It was something like once you understand this, it'll be obvious or something.
Right. Yes. Everything is obvious once you understand it. That's not helpful. Yeah. But you see, I mean, people will do that and they'll go, okay, I've said it's going to be obvious once you understand it, so I'm covered. It's like, no, you're just deluding yourself.
Yeah. Cool. Well, thank you so much, Magnus. Very nice to meet you, and hopefully we can get together in person somewhere sometime and do some fun Flix hacking.
Thanks for having me on. It was fun.
Thanks, and thanks for the great language. I think there's a lot of really, really amazing stuff here. So, thank you.